Okay, why don't we open up our science notebooks to our table and our focus question that we've been working on this week. Throughout this unit of soils, the students have been looking at different soil components, clay, sand, and humus. They were spending time identifying properties of each of those soil components through testing. They did a roll a ball test where they added water to a soil component, and then they had to roll it in their hands to see if the soil would stick together and form a ball. They were also asked to do a settling test where they put that soil component in a test tube, fill it with water, and then shook it. And then they were watching how the particles settled to see how quickly they settled, also to see the quality of the water and how it changed after a day or two. They also did a smear test, and through that they were looking at the colors, they were looking at the size of particles. So coming to today, they were taking all their knowledge about the properties of the sand, the humus, and the clay, and applying it then to trying to identify what was in our local soil.
There's still a big wood chip on the top.
The tests that we had done before today on the local soil were the roll-a-ball test and the settling test. For now, we have one more test. Does it confirm or does it change our thinking? What evidence have we collected from our soil test? So the engagement piece of this lesson started with them reviewing the focus question. Then from that, we reviewed their data table that led right into a prediction of what they thought would be in their local soil in the test that we were going to do today based on the evidence from the tests that we've done before.
Well, if we see wood on the smear test and that was from humus, then we might think there's humus in there.
Okay.
There might be like yellow marks because last time there was yellow on the smear test for sand and all the particles fell off.
If it's sand, there would probably be like little dots that look like rocks.
And so everybody that made a prediction was able to go back and support it with evidence from before. What are we calling those dots?
Particles.
We're calling those dots particles. Good. We have our objectives of the science that we want them to learn, but I also have an objective that I want them to be a thinker and to be able to explain their thinking and to be able to write about their thinking.
And the sand didn't really make a ball. So that's why I think it's sand.
You're thinking that perhaps that's evidence saying that they're... From there, then, they're actually doing some sort of investigation.
Right there, I see some black and
I can
white.
even see some light brown too in there.
This active learning time, it's hands-on and it's thinking.
that can give us evidence about sand and humus.
And they're having discussions, and they may be learning something from their partner because their partner has something else to say that they haven't thought about.
I think there must be sand in it, don't you? See?
We're really teaching them how to be observers and how to use their senses.
Feels rough.
Feels rough? The texture? What else?
Well, it's really dark when it gets water.
So it got darker with water. It's rough. So do some talking with each other about what you think is in your local soil based on evidence from your smear test. And does all this other work that we've been doing support your new data? So when the students are doing an active investigation, that time is a great opportunity for me to go around and ask them questions to further their thinking or to take it to the next level. But think about our smear test from before when we did the sand. What happened to those particles?
They fell off. They fell off.
They didn't stick, did they? And from before in the settling test with sand, how did the particles settle?
It settled quickly.
And do you have evidence that these particles settled quickly?
Yes,
How do you know that they settled quickly?
because they're at the very bottom.
They're at the very bottom. We have found that the more the students talk and discuss and interact while they're doing the test, the more they have to write or record, and then the more they have to say during our classroom discussions. Okay, so next, after we've been doing this great science work, I think we need to come together and talk about it, add to our classroom data table, and see if we're all finding the same evidence. So when I say go, I'd like you to stand up quietly and come meet me on the rug. I try to use transitions in my classroom, having them get up and move to the rug is a way just to sort of break the lesson up and to give them that chance to move around. And then when we're on the rug, it really provides an environment for them to be together, to have a conversation. Now that we've done our settling test observations for day 2 and our smear test, will you share with me some of the observations that you've been making? The shared discussion time is definitely a time where I sit back and I'm just the facilitator. Pauline.
The water wasn't very clear.
So the water wasn't clear. Carter.
There were particles floating at the top of the tube.
Some of them were still settling slowly. Soil stuck to the tube.
Okay.
Black particles at bottom.
Okay. Any others? I want to listen to them and hear what they have to say, and also facilitate the students listening to each other, again, so that they're learning from each other and adding to their ideas and their experience that they had just had in their investigation. What about our smear test? What did you observe today? Hazel.
When I felt the smear that I just did, it felt rough.
It felt rough. And another word that we can use for feel is
Texture.
the texture. Sometimes the vocabulary is not natural for them to use. I'm always just making sure that in the discussion I'm using the words, the vocabulary that is more scientific. Was it all rough?
No.
The more we do that, then the more natural that vocabulary comes for them. What else did we observe in the smear? Jonah.
Particles falling off.
Particles falling off. Now that we have all of this evidence and we have our data table complete, as scientists we need to write a conclusion to communicate what we found out to be in our local soil and then back it up with our evidence. So as a scientist, we're going to write a scientific conclusion. What's a conclusion? It's taking all the evidence, using it to prove what we think is in our local soil. So let's talk about the tests that we've done this week. Using those tests, can we identify what is in our local soil?
Yes.
So help me out. Let me know. What do you think? And then use the evidence from your testing. Heidi.
I think those sand, because in the roller ball test, we could not make a ball. And
Before I go into a writing session, I like to spend time reviewing the lesson that we have just completed
balls can't stick together.
to make the ball. Okay, good. Abby.
I think there's humus because I saw some particles that were floating up in the settling test.
It reinforces all that we've learned, and it sort of brings it all together, all the pieces together from the very beginning of the lesson to the point that we're at now. And it also provides another opportunity for me to model the vocabulary, which really lends itself to the writing piece that's coming up.
In the settling test on sand, the sand, I
And
think.
Francesca, I'm going to stop you because I want you to use words that a scientist would use. And a scientist would start by saying, I think there is sand. If I want my students to write like scientists, I need them to speak like scientists. Start with that.
I think sand's in local soil because it reminded me of.
And that needs to be taught. And I have found, though, that they're very open to me stopping them in mid-sentence. And I'm going to stop you again. What went down quick?
Sand.
And we can also talk about
The particles.
the particles. Fantastic. I need to model that language and guide them to using the more scientific vocabulary. And I see their eyes light up, and I see sort of them sit up straighter because they know they're using a more, what sounds sort of a smarter way of talking. Then it becomes second nature for them, and they start using it without me prompting them, and then I see it come out in the writing as well. So let's figure out how to write a scientific conclusion. And one way to do that is to first identify what is in our local soil. To begin the shared writing time, I asked them what they thought was in our local soil. To start, we would write, I think, and I scaffolded that by writing, I think local soil has, and then ask the students to help me to complete that sentence. And now you need to help me. Has, and that's when they gave me humus and sand. Melanie.
Humus.
Humus. Bryce.
And sand.
And sand. Good. I continued on with the students by having them then provide evidence using the scaffolding, my evidence is. Carter, what do I need to do?
My evidence is.
We need to provide the evidence, and she just gave us the starter. My evidence is. And through that, then the students were able to help me write what they observed.
White and gray particles that went down to the bottom quickly.
Good. And when you're talking about went to the bottom, what's another word that we can use that goes along with the test that we were doing? When they went to the bottom, they settled. White and gray particles that settled quickly. Fantastic. If I had just put a scaffolding on the board and expected them to write from it,
It's sand because
the students wouldn't have been successful in the settling test from before. And through the shared writing, I'm using their evidence, I'm using their data table,
floating at the top.
I'm continually activating their thinking. There's a lot of processing going on there. How can I write that I have something else to say? I can use also, and I can also use in addition. That's right. The words in addition and also I find to be really powerful because the students get stuck. They know what they want to say, but they don't know how, after finishing one thought, to go to another thought. That's how I can start. Also, what's more evidence from a different test? Nicole?
Roll the ball
We
test.
can use the roll a ball test. Do you remember, boys and girls, were we able to roll a ball with sand from before? No. What were we able to really do well with when we rolled a ball?
Play.
Clay rolled the ball. So if we want to talk about the roll a ball test, how could we use that as evidence in our writing?
2 days ago, we couldn't make a ball.
So the more chances that they have to say it, help me write it, roll a ball, and see it on the board, and then just see the scaffolding and going into their own independent writing, there's a lot more success. And help me finish that sentence. So that is why I think, Alex,
Sand and humus is in the
local
soil.
fantastic, and that's it. I have seen that providing them the structure and the instruction and the modeling, that they can go back and do the writing. And now I want to give you a chance to use your tables from your results of your tests. What I find is that this sort of process evens the playing field for all students. And now I'm just leaving the sentence starter for you and the words that can help you write your scientific conclusion. Some students need more individualization, and so I may lessen the amount of writing that they do, and I may have to provide them even more scaffolding. For some students, they don't need much of the scaffolding. They have internalized the thinking and the shared writing that we've done, and they're able to do the writing, but use their own language as well as using the vocabulary terms. So it doesn't provide a lid for them. It can let them go as far and as high as they want to go. You doing okay? As a beginning teacher, it was a difficult process to start because I had to learn the science unit itself. Then adding on a writing component to that, it at first seemed like one more step, one more thing that I had to do. But as the second year came and the third year, I began to see that one without the other was not a strong science program, that the science facilitated the writing, and the writing made the science even stronger because it was allowing students to think at a higher level that made them even more successful throughout other science units and going into the next grade.